What's going on YouTube? It's your boy Eric over here, and today I got something good for you once again. I got a problem here. Soil mechanics. Again, to all my engineers out there, hey, soil mechanics is one of the essential classes that you gotta take, and you've gotta be able to learn how to do some of these problems. And today I will be doing a stress problem, effective stress, and a stress problem. As you can see from the question up top, that is the question we're going to be reviewing today. And so get your mind right, get your body right, and hey, let's go for it. All right, so I'll just go through the question one more time. The question says, a soil profile consists of 5 feet of soil, and then you got a unit weight of 115 PCF, over 10 feet of soil. Then you got another unit weight over there, 125 PCF, over 10 feet of soil. Then you got another unit weight over there, that's 130 PCF. Then we're told that the water table is located at a depth of 10 feet. All right. Calculate the total and effective stress at a depth of 3 feet, 10 feet, and 25 feet. All right, everybody. So here's the question. What do we do? Let's do it. All right. So the first thing you got to be able to do is kind of make a very simple diagram here for yourself. That's going to ease the work for you and just going to make the questions a little bit simpler. All right. So soil profile consists of 5 feet of soil. All right. So we're going to draw a little simple diagram here, just explaining what's going on in the problem. All right. Okay, here I go. So this is going to be my soil profile, okay? This is going to be the 5 feet they're talking about. So that's 5 feet, all right? And then I have the unit weight here of 115 PCF. PCF is just pounds per cubic feet, all right? And then beneath that lies another layer. And this time we have at 10 feet, as you can see from the question here. And we have a total unit weight of 125 PCF. All right, cool. Then finally we have yet another layer down here, and that's given 10 feet. All right, so just draw it right there. Just kind of make sure everything isn't. You indicate whatever's given in the problem. All right, and the unit weight is 130 PCF. All right, cool. That's it. Are we done? All right, so let's get into the problem now. And then the problem goes ahead and says the water table is located at a depth of 10, okay? So what does that mean? That means that I'm just gonna draw something like here, indicating the water table, all right? And this is at a depth of 10. So that means that this is 5, because 5 plus 5 gives us that 10 we're looking for, which is located at the water table. All right, so what does that mean? It means that everything that's going to come below the water table consists of water, right? And then everything up top the water table is not going to be affected by water at all, okay? As we'll see in the problem. All right, so let's get right into it, everybody here. So, so the question says, find depth at 3. So I'm going to say Z equals to 3. All right, that's how I'm going to start. Okay, we do know our formulas. What is the formula for finding stress? Stress is just simply the unit weight times the distance. All right, so my distance is going to be 3 feet times, and what is my unit weight over here? 115. So come back here and just 115, and that's going to give us 345 PSF right now, okay? All right, so that is my stress. Then I come down here and I calculate my effective stress. Now again, since the water table is above 3, a depth of 3, that implies that the water is not going to be, the effective stress is not going to be affected by water at all. So that leaves us with just 345 PSF once again, all right? All right, and that will be it for the depth of 3. So let's move now at a depth of 10 right there, okay? 10 feet. This was 3 feet, now we're working with 10 feet. All right, so let's see what's happening at 10 feet. Now, at 10 feet, we have the 5 feet, and then we have the 10 feet. Now, 10 feet is exactly where the water table is. So that means it's still not going to be affected by the water, all right? So let's get the stress. Stress is going to be just simply 115 times the 5, okay? You got to take care of this first depth right here, okay? That's going to be 5, and then we also have an extra 5 right here that I got to take care of, all right? So that means I'll have to add here another 5 times, what's my unit weight down here? It's 125. So the first 5 I consider the 115 PCF, then the second time I consider the 125 PCF, all right? Cool. So I'm gonna have 125, all right? So this will give me 1,200 PSF. Yeah, there we go. There we go. All right, so calculate my effective stress. Once again, the water table is at 10, okay? It's located at 10 feet. And the depth we want to consider right now is 10 feet. So it's just right on. What does that mean? It means that the effective stress is not going to be affected by the water. So in that case, my effective stress equals to my stress, which is 1,200 PSF. All right, boom, finish. Next, depth when Z equals to 25. Now this is the big daddy here. This is where the trick comes in. All right. Now 25. What does that mean? Come back to our little diagram right here. Okay. So you notice that the first layer we have a 5 feet. Okay. The second layer you have 10 feet. So that means that gives us a total of 15 feet. All right. And then you need an extra layer of 10 feet down here. Okay. To make it equal to 25. All right. So here's what we're going to do. So my stress is going to be equal to 115. I apologize for that. Oh my God, I'm becoming slobby here. 115 times 5. And what I've done basically is just taking care of the first layer here. Okay. The 115 times the 5 plus. Okay. Now I'm going to consider the 10. This distance here, okay? So that's going to be 10 times. And what's my unit weight over there? I have it as 125, okay? So it's going to be 125 plus. So now what I have as my total distance here, as you can see, is just 5 plus 10, that's 15. And since we're heading to 25, I need 10 more feet, okay? And that's what I'm going to put right here. 10 times. And we're given the unit weight here, all right? Notice we're given the alpha equals to 130. So that's what we're going to put right here, 130. So this is going to give me a total of 3125 PSF, all right? You can use your calculators for this part. It's just simple algebra, all right? Cool. Now, my P dash, which is my effective stress. This is where the trick comes in, all right? And now, since 25 is below 10, that means the water table, or rather effective stress, is going to be affected by the water, all right? And let's see how this pans out to be. All right, so the first thing we're going to do, again, 115 times 5, all right? Cool, plus 10 times 125, okay? So what I've done, again, I've taken care of this distance, and I'm taking care of this distance right here. So now, when I get here, this is where the trick comes in. Plus, I'm going to consider the water. Since now this is where the water table is going to come into play. I'm going to say 130 minus 62.4 times my distance 10. So look what's happening here. I have a distance of 5 feet and I have a distance of 10 feet. That being equal to 15, all right? And this 10 feet here is gonna make me go to 25 feet, which is exactly what the question wants, all right? So boom, there you have it. Now the 62.4, that's just a unit weight of water, okay? And that's the actual purpose of why we subtract the 130, which is the unit weight of water, which is provided here, minus the unit weight of water itself, okay? So there you have it. And this ends up giving us 2501 PSF. Boom! There you have it. Soil mechanics. Interesting, nice, short, sweet. Love it. Don't we all just love civil engineering? Alright everybody, there you go. Just had something small for you today, and I hope you loved it, hope you enjoyed it. And go out there and shine. Keep your feet on the ground and keep getting those stars, baby. Alright? Alright.